A welder can have the best machine, the highest quality filler metal, and years of experience, yet still struggle to produce a strong weld if they are working in the wrong position or don't understand how welding positions affect the weld pool. One of the biggest challenges in welding isn't simply melting metal together, it's controlling molten metal against the force of gravity. Whether you're fabricating a steel structure, repairing heavy equipment, building pipelines, or manufacturing vehicles, the position of the weld can dramatically influence weld quality, penetration, bead appearance, and overall strength. This is why professional welders spend countless hours mastering welding positions before working on critical projects. In fact, many welding certification tests are designed specifically to evaluate a welder's ability to perform quality welds in multiple positions. As modern fabrication continues to advance with robotic welding, automated positioning systems, and AI-assisted welding technologies, understanding traditional welding positions remains one of the most important skills every welder must possess. In this guide, we'll explore what welding positions are, why they matter, the 4 primary welding positions, their challenges, applications, and the advanced 6G position that many consider the ultimate test of welding skill. Let's get started. What is a welding position? A welding position refers to the orientation of both the welder and the workpiece during the welding process. Simply put, it describes the angle and location where welding is performed. Welding positions are important because gravity directly affects the flow of molten metal, weld penetration, bead formation, slag control, welding speed, and overall weld quality. A position that may be easy for one application can become extremely difficult in another due to the way molten metal behaves. The 4 basic welding positions are flat position, horizontal position, vertical position, and overhead position. These apply to both groove welds and fillet welds.
Understanding welding positions codes. Professional welding positions are identified using a combination of numbers and letters. Groove weld positions: 1G, flat groove; 2G, horizontal groove; 3G, vertical groove; 4G, overhead groove; 5G, fixed pipe position; 6G, inclined pipe position. Fillet weld positions: 1F, flat fillet; 2F, horizontal fillet; 3F, vertical fillet; 4F, overhead fillet. The letter G stands for groove weld, while F represents fillet weld. Understanding these designations is essential when reading welding procedures, certification requirements, and engineering drawings. Why are welding positions important? Many beginners underestimate the importance of welding positions. However, the position directly affects weld quality. Proper positioning helps create consistent penetration and fusion. Productivity. Some positions allow faster welding speeds than others. Safety. Working overhead or vertically introduces additional hazards from falling slag and molten metal. Accessibility. Certain structures and pipelines can only be welded from specific angles. Certification requirements. Many welding jobs require certification in multiple welding positions. Mastering these positions makes a welder more versatile and employable. The 4 main types of welding positions. Let's explore each position in detail. 1. Flat welding position, 1G and 1F. The flat welding position is considered the easiest and beginner-friendly welding position. It is also known as the downhand position because the weld is performed from above the joint. In this position, the workpiece lies flat. The weld is deposited on the upper side of the joint. Gravity helps the molten metal flow directly into the weld joint. Because gravity works with the welder rather than against them, controlling the weld pool becomes significantly easier. Advantages of flat welding: highest welding speed, excellent penetration, easy pole control, minimal welder fatigue, better bead appearance, easier to learn. Challenges: Although relatively simple, improper travel speed or excessive heat input can still create undercuts, burn-through, or excessive reinforcement. Common applications. Flat welding is commonly used in structural steel fabrication, manufacturing plants, equipment assembly, and workshop fabrication. Most welding students begin learning in the flat position before advancing to more difficult positions.
2. Horizontal welding position, 2G and 2F. The horizontal position introduces a new challenge. Gravity begins pulling molten metal downward along the vertical surface. In this position, the weld axis is horizontal. The weld face is generally vertical. The welder works across the side of the joint. Unlike flat welding, the weld puddle tends to sag toward the lower edge. This requires greater control and precision. Advantages of horizontal welding. Suitable for large structures, allows welding on installed components, common in industrial fabrication. Challenges. Welders often encounter uneven bead shape, sagging weld metal, difficulty maintaining penetration, increased risk of undercutting. Proper electrode angle and travel speed become extremely important. Many welders maintain approximately a 45-degree torch angle to improve puddle control. Common applications. Horizontal welding is frequently used in shipbuilding, bridge construction, pressure vessels, and structural steel projects. 3. Vertical welding position, 3G and 3F. Vertical welding is considerably more challenging because gravity continuously pulls molten metal downward. In this position, the weld axis is vertical. Welding occurs either upward or downward. There are two main approaches. Vertical up welding. The welder starts at the bottom and moves upward. Advantages include deep penetration, strong welds, and better structural performance. Vertical up welding is often preferred for thicker materials. Vertical down welding. The welder starts at the top and moves downward. Advantages include faster welding speed, less heat input, and suitable for thinner materials. However, it generally provides less penetration than vertical up welding. Challenges. Vertical welding requires excellent puddle control, proper weaving techniques, and careful heat management. Without proper technique, weld metal can sag or pile up. Common applications. Vertical welding is commonly used for structural columns, storage tanks, pipe systems, and construction projects. Many industrial welders consider vertical welding a true test of skill. 4. Overhead welding position, 4G and 4F. The overhead position is widely regarded as the most difficult of the four primary welding positions. In this position, welding is performed from underneath the joint. Gravity constantly pulls molten metal downward toward the welder. The challenge is obvious. Molten metal naturally wants to fall out of the weld joint. Advantages. Although difficult, overhead welding is often unavoidable when working on pipelines, structural frameworks, bridges, and industrial equipment. Challenges. Overhead welding introduces several difficulties: falling slag, molten metal droplets, reduced visibility, increased welder fatigue, and greater safety concerns. Welders must maintain a smaller weld puddle and carefully control heat input to prevent sagging.
Safety considerations. Extra protective equipment is essential during overhead welding because hot metal and slag can fall directly toward the operator. Proper helmets, flame-resistant clothing, gloves, and safety gear are critical. Understanding fillet and groove weld positions. The four basic positions apply to two primary weld types. Groove welds, G.
Groove welds are used when joining two pieces of metal edge to edge. They typically require full penetration, strong structural integrity, and precise joint preparation. Examples include pipe welding, pressure vessels, and structural steel. Fillet welds, F. Fillet welds join two surfaces positioned at approximately 90 degrees. They are commonly found in frames, brackets, structural supports, and general fabrication. Fillet welds are generally easier to perform than groove welds, but still require proper positioning. What is the 6G welding position? When welders talk about the toughest welding certification, the conversation almost always leads to 6G. 6G welding position involves welding a pipe fixed at a 45-degree angle. Unlike flat or horizontal welding, the welder cannot rotate the pipe. Instead, they must weld around the entire circumference while constantly changing positions. During a single weld, the operator transitions through flat welding, horizontal welding, vertical welding, and overhead welding. This makes 6G one of the most demanding welding tests in the industry. Why is 6G important? Many employers use 6G certification because it demonstrates a welder's ability to handle nearly any welding situation. Common industries using 6G welders include oil and gas, power plants, petrochemical facilities, refineries, pipeline construction, and industrial manufacturing. A welder who can successfully pass a 6G test is often considered highly skilled and versatile. Modern advancements in welding positioning. Technology is changing how welders work with difficult positions. Modern advancements include robotic welding systems. Industrial robots can maintain precise torch angles regardless of weld position. Positioners and rotators. Automated workpiece positioners rotate workpieces into easier welding positions, reducing operator fatigue. Smart welding machines. Modern machines automatically adjust parameters based on position changes. Augmented reality welding training. Virtual welding simulators allow students to practice various positions safely before handling real equipment. AI-assisted welding. Artificial intelligence can monitor puddle behavior and recommend adjustments during welding operations. These technologies improve consistency while helping welders tackle challenging positions more effectively. Best practices for welding in any position. Regardless of position, successful welding depends on several key factors. Maintain proper travel speed. Moving too fast reduces penetration, while moving too slowly increases heat buildup. Use correct electrode angle. Proper torch or electrode angles improve bead appearance and penetration. Control heat input. Excessive heat can cause distortion and burn-through. Practice consistently. Position welding improves through repetition and experience. Follow safety procedures. Different positions present unique hazards that require proper protective equipment. Conclusion. Welding positions play a critical role in determining the quality, strength, and appearance of a weld. The four primary positions, flat, horizontal, vertical, and overhead, each present unique challenges and require specific techniques to master. Flat welding offers the easiest learning curve, while horizontal and vertical positions demand greater puddle control. Overhead welding remains one of the most challenging due to gravity working directly against the welder. Beyond these basic positions, advanced certifications like 6G push welders to demonstrate complete mastery of multiple welding orientations in a single test. As modern welding technology continues to evolve through robotics, automation, AI-powered systems, and advanced training simulators, understanding traditional welding positions remains a fundamental skill for every welder. Mastering these positions not only improves weld quality, but also opens the door to greater career opportunities, higher certifications, and success across virtually every welding industry.